So I think that's everything for the housekeeping. So without further ado, I think I'll hand over to Alex. I hope you're able to share your screen.
Well, yeah, we've got to. It's a bit of a novelty, this. I've only ever done one other presentation, so apologies in advance if I managed to not manage to successfully share screens. But we had a dry run at this, and it did eventually work. So let me see what happens, shall we?
There we go. Yeah, we can.
Is that looking correct?
Yeah, I can see your screen. That's great.
All right. So, and then if I press that button, does that take you to the next screen?
Yeah, that's
yeah, fantastic. This is a success. All right. Well, that's the end of the show. I'm afraid that's it, and I must go. Good evening, everyone. Thank you very much for coming along. This is slightly unusual, kind of not doing it in front of a live audience. I definitely prefer real human beings as opposed to sort of doing it all digitally, but we'll give it our best shot. So just I won't bore you too much about ourselves, but Enhabit is part of a group of companies that also owns green building stores. So we get heavily involved with anything to do with low energy buildings in terms of design and also the sort of supply and manufacture of windows and all sorts of bits and pieces. So we're part now of a larger company, which means that we have more resource. And as a company, we're getting heavily involved with retrofit type projects in the public sector, which seems to be really interesting at the moment. I won't bore you about this, as I say, because I've got quite a few bits and pieces to wander through. So just in case you're a bit worried of who am I and do I really know anything, I'll just quickly sort of introduce a little bit about my background. So I did a civil engineering degree many years ago. I then spent 10 years in the cement and concrete industry in various roles. I had the pleasure of attending a few manufacturers advisory group meetings at the BRE in Watford when they were putting together the original Green Guide, which was quite sort of fascinating in terms of understanding how different trade organisations try and sort of outdo one another and try and offload their carbon emissions onto another industry. So quite interesting kind of getting involved with those. And then I spent 4 years working for a cement manufacturer that was using waste materials. So that's ground granulated blast furnace slag as a cement replacement material. And that's what sort of first got me interested in materials in the built environment. And then, as I say, we do quite a lot of Passivhaus tradespersons training. I was lucky enough to be clerk of works at Goldsmith Street. I do energy calculations as a SAP assessor. I can also do some air testing and MVHR commissioning. And I also hold a health and safety qualification. So I get involved looking at CDM on site, which is often provides lots of fun. So that's me. So what are we going to talk about? Let's have a look. So what is Passivhaus? I'm hoping that most of you are familiar with Passivhaus, so we're not going to linger on it for too long because we want to talk a little bit about materials. At the end of the day, Passivhaus is a comfort standard. It's about making homes comfortable to live in, and something of an anathema perhaps to our industry, but that's the basic tenet of Passivhaus. And it concerns itself with producing very low energy demand buildings. It's not particularly bothered about what the heat source is. The idea is that if so little energy is required to heat the building, that actually it doesn't really matter if you burn a little bit of oil or a little bit of gas or use mains electricity. It doesn't really get that upset. It's all about reducing the energy or the heat demand overall. And it's not particularly bothered about how you build it and what sort of materials you use, although as we'll see later on, that is perhaps changing. So I'm going to kind of start off by asking, why low energy buildings? Why don't we just build, as we've always done, build really poorly performing housing and other buildings and just ignore the whole thing, just carry on? So I think it'd be worth just spending a few minutes talking about low energy buildings and why they are important to us. So the government envisages that we'll mainly go over to electric and or sort of district heating. But the problem with that is that currently something like 85% of homes in the UK are provided by gas heating. So your sort of combi boiler or your system boiler at home gurgling away. 85% of homes have those in there. And if you look at the actual amount of energy that's supplied per year in terawatt hours, you can see that the gas grid is twice as large as the electricity grid. So if we decided to go electric and we didn't do anything to our building stock in terms of energy efficiency, the electricity grid, as you can see, would have to be 3 times bigger almost instantaneously if we switched the gas grid off and we moved over to electric heating. Now, they reckon, people far cleverer than myself reckon that to actually meet peak demand, the electricity grid actually would need to be 6 times bigger than it is now in terms of capacity to kind of be able to handle that increase in terawatt hours. So as a nation, if you're looking at it at a national level, we can't carry on building really poorly performing homes and other buildings, simply because if we do move to electric heating, we won't be able to kind of keep the lights on and provide all that that heating via electricity alone. So it's going to be really important that we actually do something about the energy demand, the heating demand of the buildings in the UK. So I'm sure you've seen it in the press, and there's lots of lobbying going on, and the politicians, bless them, aren't necessarily the world's brightest, and they're all going, oh yes, that sounds like a great idea. So why not hydrogen in the home? So this is a bit of a personal kind of beef about hydrogen in the home. The idea is that they're going to make hydrogen with sort of leftover or excess green electricity, but it's a really, really inefficient way of getting heat or energy to your house, and actually probably putting in an air source heat pump in your house in terms of overall efficiency of the system is probably a factor of about 8 better to putting in the heat pump. So it just doesn't seem to make any economic or financial sense to try and put hydrogen into the homes, because if we derive the hydrogen from the electricity through electrolysis, it's just really, really inefficient way of doing it. And it's nobody wants to talk about embrittlement, and I'll leave you to Google embrittlement. It's where hydrogen kind of gets into metals and plastics and things and breaks them down. The cost, the actual running cost of hydrogen is incredibly expensive at the moment, and may come down, may not. And then leaks. As a nation, we struggle to keep water in pipes. I can assure you that hydrogen as a molecule is quite a bit smaller than water. And if we can't keep water in a pipe, we're probably going to struggle to keep hydrogen in a pipe, I would suggest. And Elon Musk, who's now edged into the 2nd richest person on the planet because he's backed, I think, the right horse, has said about hydrogen in cars as staggeringly dumb. And I'm with Elon Musk on that. So anyway, so low energy homes. Obviously, our delightful government announced their 10-point plan this week, and we're all going to go around putting in some loft insulation, and we're all going to put in some triple glazing. And for about a period of about an hour and a half, the Future Home Standard did get a mention in the 10-point plan, and then it mysteriously disappeared. Now, we can only assume that Persimmons, like they did with killing off the zero-carbon homes back in 2015, we can only presume that Persimmons rang the government up and said, how dare you put in the Future Home Standard into your 10-point plan to save the planet, and we want to carry on building really poor quality houses. So it disappeared after 90 minutes this week. So it's fascinating to find out whether or not we actually get the Future Home Standard that has been kicking about now for over a year. So what is the Future Home Standard? Well, effectively it's Passivhaus, but without the hard bits. So what I mean by the hard bits is linear thermal bridging, which we'll touch on, airtightness, which we'll touch on, and indoor air quality, which we'll touch on. What it does talk about in the Future Home Standard is sort of Passivhaus levels of insulation to the floors, walls and roofs. It talks about putting in triple glazing, and ideally putting in sort of wastewater heat recovery, and potentially looking at sort of heat pumps and other sort of heating sources. But it's as I say, it's Passivhaus, but without the hard bits. So let's talk about the hard bits. So here you have a pretty standard internal wall detail. And we're going to be talking about materials in a bit. And I'm just going to say, is there any point in carefully selecting your materials and worrying about embodied carbon in your materials if you're not going to put the materials together very well? And then in this instance, you can see that actually the blockwork provides a fantastic linear thermal bridge. Now, linear thermal bridges, they're a funny thing, linear thermal bridges, because the more insulation that you throw at your building, the bigger the thermal bridges become in importance of your total fabric heat loss. So if you put lots and lots of insulation in the roof and lots of insulation to the walls and lots of insulation to the floors, there is a possibility that the extra heat loss at the thermal bridges could account for 30% of your total fabric heat loss. So it's absolutely fundamental that if you're going to design a low energy house, that you really think about how you're going to join the bits together. I could do a whole evening on linear thermal bridging, and I'm sure I'd bore you rigid, but I'm not going to do it to you this evening. You'll be pleased to know. But anyway, linear thermal bridging isn't really included in the Future Home Standard, and I think it should be. Airtightness, yes. Right, so this is from a very surreptitiously stolen a section drawing from Mikhail Rich's from Goldsmith Street, because this is a passive house building, and it does actually show, just press another button, it does actually show you where the airtightness layer belongs on the drawings. Now, I do lots and lots of energy calculations. I'm a very sad geek, and I get lots and lots of drawings from lots and lots of lovely architects and architectural technicians. And it's pretty unusual to see the drawings actually identifying correctly where the airtightness layer should be in the building. And it's normally left to the builder to sort it out. And what they tend to do is to go to Travis Perkins and buy a roll of that silvery tape, and they start sticking it here, there, and everywhere. And after a couple of weeks, it kind of falls off again. And so we don't really, as an industry, get airtightness layers very well. And it isn't actually a dark art. It's really simple. You take a section drawing and you draw a red pen around where you think the airtightness layer needs to be. And if you don't put in an airtightness layer, then probably your building is going to leak air, and therefore it'll leak heat. And the other thing that you need to worry about is an average sort of family on an average day will probably produce about 11 litres of moisture. If you do not think about where that moisture is going to go, especially in a timber frame, there is a chance that you might end up rotting the timber frame. And here we are, we're talking about embodied carbon, we're thinking about building materials, and we're trying to think about how we're going to make these buildings last a long time and be really energy efficient. And if we don't think about an airtightness layer and the thing rots after 20 years, it kind of rather defeats the object of building low carbon, low embodied carbon buildings. So airtightness layer, really important. Yes, indoor air quality. So as part of the research that went behind the Future Home Standard and the Part L consultation document, it was admittedly a very limited piece of research, but it was interesting nonetheless. The research indicated that the indoor air quality of the houses that were visited was so poor as to promote poor health. The research indicated that only 4% of homes fully satisfied Part F of the building regulations. Let that sink in. 96% of new buildings are failing occupants. Increased air tightness in modern homes is making the problem worse. And so I asked the question, how much longer are we going to build this stuff? How much longer are we going to build buildings where we don't think about the indoor air quality and let the occupants down? And especially in COVID this year, it's one of the big things that everybody's been talking about is indoor air quality. And if you happen to go to your local Sainsbury's, you might actually hear the ventilation system going 10 to the dozen, trying to push in loads of extra air, fresh air into the building, because we've never really set ourselves up to actually think about indoor air quality correctly. And I would just say that Passivhaus forces the designer to design, actually, the ventilation system. And Passivhaus will supply the correct amount of fresh air per occupant, irrespective of the weather. So indoor air quality is really important. And it's not really in the Future Home Standard to any degree. So I'm going to get off my horse, and we're going to talk a little bit about embodied carbon. So what is it? So because I'm but a simpleton, so I like the simple things. So it's basically the carbon dioxide emissions associated with making a building, which I think is kind of pretty sensible, nice way of putting it. And if you want the posh one, it's more precisely embodied carbon covers greenhouse gas emissions that arise from the energy and industrial processes used in the processing, manufacture, and delivery of the materials, products, and components required to construct a building. So that's what embodied carbon is. So what's the problem? Well, if and when Persimmons let us build low energy homes en masse, our total carbon emissions will actually start to drop in terms of the carbon emissions that are derived from using the build, from in use. So our gas bill, our electricity bill, or whatever, that will start to drop. And as that drops, those carbon emissions that are used in operation of the building, as they drop, the proportion of the embodied, or the proportion of carbon that's tied up in the building becomes more and more important. So as we get better and better at building low carbon, we get better and better at building homes that require less heating, and where our carbon content goes down in terms of our carbon emissions from operating the building, it becomes more and more important that we think about the embodied carbon of the building. And it's envisaged that probably by 2050, when we're doing really good low energy buildings, that probably embodied carbon will add up to about 40% of the total carbon of that building in its whole lifetime. So it's going to become more important over time. And I can't kind of emphasize that enough. That's the issue. It's going to become a bigger issue. We're going to get asked more about embodied carbon as our buildings get more energy efficient. It becomes more important. So what is the solution? Well, the classic, and I kind of found this, the little classic little symbol, reduce, reuse, recycle. We get told to use this when we're kind of thinking about stuff in the home, but equally you could think about it, about the home itself. And so we could reduce, and what I mean by that is our need for new buildings in the first place. Working from home this year has perhaps made us think about making buildings more adaptable, so that perhaps we need fewer buildings. I was talking to somebody at a university recently that said they think there's probably on their university estate they might have 10,000 square meters of building that they really haven't got a use for anymore. So it does make us think about, do we actually need to go around building lots and lots of new buildings? Because it's not very green and environmentally friendly building new buildings, to be honest. Let's be honest with ourselves. So reuse, can we repurpose existing buildings, sort of via material change of use? And perhaps COVID again has been a really interesting kind of thing this year, in that it's really pushed buildings that perhaps are, certainly the high street is going to be repurposed, I would argue. And I'm aware of quite a few projects in the city where certainly the upper stories of quite a lot of department stores are looking to be converted into housing of some description. I have to say, a lot of it isn't done very well in terms of energy performance, but that's for another subject, for another day. Finally, if we are going to build buildings, is there an opportunity to recycle the materials from buildings that we're knocking down? So, could we sort of use the crushed concrete, etc.? Could we reuse the steel sections from buildings? And equally, could we actually use sort of large foundations as opposed to taking the whole building down right to the ground or into the basement even? Is there an opportunity with big buildings to actually reuse the large foundations? So what I'm sort of implying is that on really, really big buildings, actually the fairly common method of construction, sort of a concrete frame, there's no reason, because of exposure classes, when you look at them, that the building will last pretty much forever. Most concrete structures, I know you have to talk about depth of carbonation and things like that, but generally speaking, most concrete frame buildings will last, if they've got some sort of facade to them, pretty much indefinitely. And so is there an opportunity, instead of having a retained facade project, you actually turn it inside out and just take the facade off and make it look really different, but actually most of your embodied carbon is retained within the original structure. And so it's sort of a heavy refurbishment. Do we really need to knock some of these buildings down? Can we reuse elements of the building and retain them? Even things just like sort of lift shafts and cores and basement areas, they could all probably be reused. Certainly in London, it's something that really we probably need to sort of pay more attention to. if you're wondering, Halton House, which is the photograph there, I was a student engineer, and that looks like a Victorian building, but actually it's a brand new office block behind a retained facade. So taking it to its sort of kind of nth degree, I'm just highlighting that if you very carefully select your materials, there's no reason why your building couldn't last 2,000 years. And if you could repurpose or reuse the Pantheon, it would be, a fantastic building in terms of its embodied carbon over a 2,000 period, 2,000 years would be negligible. If you looked at, sort of CO2 of carbon per year, it would be, and that's what's it. So there is an opportunity to really think about buildings perhaps in a different way, as opposed to, just build a new building. So, okay, you've decided you can't reuse the building. There's nothing you can do with it. You want to build a new building. So it has to be new build. Then what? Well, obviously, from what we've already discussed, it needs to be a low energy building. So that's a given. It has to be a low energy building. And if we are going to use, if we are going to build a new building, is there an opportunity to use recycled materials? Is there an opportunity to use locally sourced materials? Is there an opportunity to use low carbon materials? These aren't always suitable, but it's worth asking the question. And we'll run through some sort of different materials and just kind of give you a sort of brief flavour of my sort of thinking, is what I have in mind. So metals, in terms of steel and obvious one, generally they are very easily recycled. And certainly in the UK, there's very much a supply chain in place in terms of to recycle those sort of materials, metals. I suppose we're all used to reading about sort of lead theft of church roofs. Metals have high value, so they are often will be recycled. So there is an opportunity to look at recycled content of the materials that you're specifying. Ideally, we want to recycle metals because the extraction of metals is often very highly polluting, and often it takes a lot of energy. Aluminium is smelted in electric arc furnaces from bauxite, and I can assure you that the lights flicker when they turn the electric arc furnaces on. It uses huge amounts of electricity. And in the bottom right-hand corner, I've put in some figures I found. I think these are Rick's figures, I think. And it's identifying the amount of embodied carbon in CO2 per kilogram of material. So if you want 1 kilogram of aluminium, it will produce about 9 kilograms of CO2 to give you that 1 kilogram of aluminium. And that, I believe, from memory, these are UK figures that do include an element of how much is actually recycled already and put back into the supply chain. So these aren't necessarily virgin material figures. These are UK figures based on recycling metals. So as you can see, aluminium is particularly bad in terms of the energy required. So when you're thinking about those really fantastic alley-clad windows that we've all fallen in love with recently, perhaps you could start to fall out of love with them. So metal frame Passivhaus, I'm not aware of any in the UK. I did find some on the Passivhaus Institute website. There's a few in Germany, and a few in France, and one or two sort of bigger buildings are in steel frame. And so I have to say, I don't know a huge amount about sort of Passivhaus. What I did sort of read up and kind of buy into is that with a steel frame, if you took a traditional sort of portable steel frame, as you can imagine where the steel frame sort of sits on a concrete pad, you have to think really, really carefully about linear thermal bridging. We don't want any heat loss down through the steel. So you do have to spend a lot of time thinking about how that steel frame works, such that the insulation goes over the top of it and that you don't end up with any thermal bridging. And also you need to make sure that the airtight barrier is onto the outside of the steel frame for it to be continuous, but it does still need to be inside the thermal envelope. So there's quite a lot to think about when you're doing steel frame buildings to Passivhaus. These are the sort of things that I have seen on sites. This is sort of METSEC, but it's the same sort of idea in terms of there's a membrane. And as you can see the picture on the left, the guys are meant to use tape sort of 50-50. But what they've actually done in this instance is about 95% of the tape is on one piece of the membrane, and there's about 5% just tickling the other piece of membrane. So that's obviously never going to join those two pieces of membrane together successfully. And that's really sort of kind of poor practice. And it's the sort of thing, unfortunately, we do see quite often. The middle photograph, this is your air tightness layer, and somebody has kindly put a nice light socket in the middle of it and ripped your air tightness layer. Now, you can have a go at your electrician, you can have a go at those putting in the air tightness layer, but arguably it's poor design. Somebody really hasn't thought this through, and they haven't put it on the drawings how it should be put together. And so there's an element of culpability, I would say, on the design team to think about the design, the air tightness layer, and how the services then kind of intermingle, if you will, with the air tightness layer. All of that cabling and everything should be down the inside of the air tightness layer. So design needs to be thought through. The photograph on the right, you can see they put the air tightness layer in, but they've decided that sort of 2/3 of the way up the wall, they've kind of run out of enthusiasm, and they're hoping that the air won't go around it. I can assure you it will. So just be careful about when you go to sites, just kind of have a look around and look up and look down and see, look at your air tightness layer and see if it's actually being installed anywhere near to a decent standard. And the other thing to bear in mind with that photograph is process. The air tightness layer up above needed to go in before that doorway went in. Because if you now try and retrofit the membrane to the top part of that wall, it's going to be really, really difficult to get an airtight seal where that doorway is. It's almost impossible. So process, think about the order in which things go into a building such that it's easy to create an airtight envelope. Concrete, I could do a whole lecture on concrete, but I'm not going to do that to you. I'm far too kind. What I would say is that roughly about 50% of the embodied carbon is in the cement, as in Portland cement, not in your waste products like pulverized fuel ash and ground blast furnace slag. Weirdly, globally, we're actually more worried about running out of suitable sand than we are running out of cement. And if we're talking about embodied energy and we're talking about sustainability, it's worth just flagging up that in London and the southeast, most of the aggregates come out of the North Sea. And so it's not necessarily a hugely sustainable source of material. You could try using crushed concrete into your new concrete. The problem that we have is a practical one. We're not very good at investing in concrete plants. And if you go to a ready-mix concrete plant here in Norwich, for instance, you won't find one that's capable of taking a 40 mil stone. And if you crush concrete down to less than 40 mil, it ends up mainly as dust, which isn't a lot of good to anybody. So we're actually hampered here locally and nationally by ready-mix plants not being able to take different aggregate sizes and different aggregates, such that we could go for a higher recycled concrete or higher recycled content concrete. So it's all a bit sort of disappointing, really. There are some cement replacement materials out there, so what we're looking at is reducing the embodied carbon of the concrete by 50% by simply removing the Portland cement from the product. And they talk about alkali activated binders. So it's kind of different chemical processes to give you the same sort of calcium silicate hydrates that hold the aggregates together in a concrete matrix. The other thing that we could do, and people are looking at doing, is to move over to hydrogen-fired cement kilns, because most of them, or all of them, burn natural gas. And this is one of the uses that I think hydrogen does have in the future. You could send electricity to the cement works, and then they make hydrogen on site and then put it into the kiln. That I kind of get, and I think it's a really good thing to do. However, limestone decomposes in a cement kiln and it drives off an awful lot of CO2 in that decomposition process. So it starts off as calcium carbonate, which is what, CaCO3, and you end up with sort of free lime, which is calcium oxide. So CO2 is driven off in large amounts as part of the process. So normal concrete is always going to be a fairly high sort of embodied carbon material, and so you need to try and minimize the amount that you're using it. But interestingly, per kilogram, and concrete is only 0.11 kilograms of embodied carbon per kilogram of product. So in some ways, it's much better than steel. ICF, hopefully you're vaguely familiar with ICF. So ICF is insulated concrete formwork. It's basically Lego bricks made out of polystyrene, and you put them together, and then it leaves a void in the middle, which you then fill up with concrete to create your structural wall. Really nice system. There's several around, Beco, Logix, there's others. In terms of putting the Lego bricks together, it's as easy as anything, pretty much, once you've got your first base course down. What I would suggest is that casting the concrete successfully is quite an art and quite tricky. And therefore, if I was doing a self-build using insulated concrete formwork, I would put the Lego bricks together, and then I'd get specialist guys in to do the concreting element for me. It can go wrong very easily. Weirdly, these buildings are cool in summer. Historically, we're told that if you have a lightweight structure, and in this case, indoors, if you think about it, it's polystyrene and plasterboard, the first couple of inches of the wall, you would be told that that's a lightweight structure and there wouldn't be any cooling effect given. But there seems to be some kind of more deeply odd relationship going on with the concrete hidden away within the structure. And so these buildings, somewhat counterintuitively, actually work really well in summer months. One of my kind of questions is that a lot of these products are a mixture of polystyrene and nylon, and then obviously you've got concrete in the middle. So the question is, at the end of these buildings' life, are they recyclable? And the other thing that is something I'd like to do is use foamed concrete, because it'd be a lower density. It would use less concrete, there'd be air in it, it'd be like an aero chocolate bar, and also it'd have better thermal properties. And I'd be really interested in trying to do an insulated formwork concrete product with foamed concrete. I'd like to do that. I've been involved with one or two ICF houses, but not as passive houses, but they have been done, like this one at Morton and Marsh, which was a Grand Designs one, in insulated concrete formwork. I quite like it as a material, but it has got a comparatively high embodied carbon. Wood, yeah, that fantastic renewable product. It is really good, and it's probably the best material out there in terms of embodied carbon. But a lot of it, most of it, is plantation wood, which isn't considered very biodiverse. And also, sort of soil erosion and soil acidification are known as problems when we're actually harvesting plantation wood. And I will also flag up, especially some of you lovely people do like your Siberian larch. It has travelled 3,500 miles to get here. So you do have to kind of wonder about the embodied carbon of hiking wood halfway across the globe. So you kind of think, well, what about local wood? Well, at the Enterprise Centre, they did use wood out of Thetford Forest for some internal work, which was sort of considered sort of non-structural as such. And so it's great because you chop the tree down in Thetford and you bring it to Norwich and you put it into the Enterprise Centre at the university, and everybody's happy, except for it needed grade testing. And so the trees actually went to Ireland to be tested and then brought all the wood back all the way back. So it went from Thetford to Norwich via Southern Ireland, which sort of seems slightly daft. So if we are going to use homegrown wood, then we need to have some UK testing facilities, or we come up with a way of using non-structural timber that doesn't need testing. The other thing about the UK is that we're a maritime environment and trees tend to grow too fast. So most of our softwood is not of a great quality, unfortunately. CLT, now some of you, ladies and gentlemen, have probably used CLT, so cross-laminated timber. I've seen it used as a lift shaft at the Enterprise Centre. It was used at Cranmer Road, a Passivhaus project that we're involved with in Cambridge. Our thoughts are it uses too much wood. Less is more. We need to use a lot less materials. We need to be much more lightweight in our thinking. Timber frame. So, quick to erect. These panels come to site, and you can put a building together, a whole house in the space of a few days if the roof structure is pretty straightforward. As soon as those fantastically able architects come up with some great ideas of big wide openings that look fantastic on drawings, you're automatically introducing steel. And steel goalposts and timber frames just complicates things in terms of linear thermal bridging, getting airtightness to work. So if you can, I know everybody loves a big, bifold doors. If you can get away from that and actually work to the maximum spans allowable within a timber frame, it would be much more beneficial for everyone. This particular system is from MBC. They're not my favourite company, unfortunately, which is a shame because the product, I actually quite like the product. But if you can imagine, Larsen Truss is 2 timber frames kind of held together with sort of nogging pieces. And those nogging pieces are held together with sort of the gang nails, which creates a thermal bridge. And it did take me quite a while to get any sort of data out of the guys to try and work out what the resulting U value of that was. But it's a great system. The green film that you can see on the OSB there is called, the product is called Smart Ply, and it gives you your air tightness layer, and it works really, really well. We had a fantastic air test result on this particular building. I think we got 0.36 air changes, which is pretty good going. Be really careful about that floor to wall junction, and people seem to want to use squeezy foam and not tape it properly to the floor. So detailing, you have to take a lot of care, you have to give a lot of thought to it. And then this particular building, and also at Goldsmith Street, they were filled with warm cell insulation, which was a system developed in Wales originally. The company went bust, all the kit went out to Czech Republic, and we now import all the warm cell, but it's basically mashed up and treated newspaper in like a pulp form. So it's a fantastic product, very low carbon. And you're quite literally recycling paper into insulation material, so really, really nice material to use. And there's some really good installers that go around putting this stuff in, and really kind of take my hat off to them. It's quite an art when you actually watch them use like a magic hoover to place the warm cell. It's one of those dark arts, so you kind of go, that's quite impressive. Clay brick. Okay, so again, quite a lot of it these days, unfortunately, is imported. So the bricks at Goldsmith Street, for instance, came from Belgium. Wienerberger is Austrian in nature, so there's quite a lot of brick that we seem to import. It's a very heavy material, so to transport it halfway across Europe is, in terms of carbon, really not a very bright thing to do. You've then got quite high firing temperatures of about 1,000 degrees centigrade, so you're using a lot of gas, so you're getting quite high embodied carbon that way. And if we went back to using traditional lime mortars, we could actually reuse those bricks over and over again. And I live in a tatty cottage here in North Norfolk, and to be able to sort of take down a little bit of lime, lime brickwork and then redo it and put it back together with lime mortar means that those bricks are 200 or 300 years old, and they're almost as good as the day they were made. They're soft Norfolk reds, so you've got to be a bit careful with them, but they're still ultimately usable. And again, I've put in the bottom right-hand corner the embodied carbon per kilogram of brick and ceramics, things like sort of wall tiles, and then lime itself. So clay brick, I like it a lot. A play on clay brick is Porotherm, which is like an aerated brick, sort of an extruded sort of brick, and they used it at Carrowbreck. A really nice product, and it's a bit like when you actually handle the material, it reminds me of sort of clay pots that you find in the garden centre. It's quite brittle as a material, so when you go to drill it, as in to put up curtain rails or kind of other stuff during construction, it's a bit of it wasn't the easiest product to use from that perspective. It's meant to be machine planed, so when you put it together, you can use thin joint mortar, and you just sort of dob it together, and there's no mortar to the perps. So you're just laying a whole spread of mortar across a wall, and then you're just dobbing these porotherms together. What the bricklayers found was that these blocks weren't quite true enough, and they were ending up with tiny little wedges here and there and everywhere to keep the brickwork up, vertical. It turned into a relatively expensive process. What I would say is that these particular buildings at Carrowbreck, it was a really hot summer, and it was a joy to go into these buildings on a hot summer's day. They were really nice buildings to be in. It's a very robust system. The other thing that I like about using Porotherm, it's a solid wall, there's no cavity in this particular method of construction, is that your external wall insulation is all on the outside, and if it ever gets damaged, you can see the damage, and it's easy enough to replace. So I quite like it as a system. It's got a lot going for it. Now we're getting into a kind of, this looks a bit more interesting. Hello, what's going on here? Hang on, sorry, I've just got something coming out on my screen. Let me just get rid of something on my screen, because hopefully, right. So cob or straw bale. So cob, which we would locally call clay lump, is do see a bit of it in Breckland in traditional buildings, and I've seen one or two buildings sort of Wyndham Way as well. So it would be a mixture of sort of straw, clay, probably a bit of cow dung, sand, and sometimes a bit of lime to sort of create lumps or bricks here locally. If you're making cob, it would be more of a sort of a round earth sort of setup. So you'd make shutters as though you're sort of doing a concrete, in situ concrete wall. And instead of pouring the concrete in, you chuck the cob in, and then you chuck a couple of children in or something suitable, and you jump up and down on it to actually compact it. It's one of the most ancient sort of materials out there, and it's a fantastic material. It's quite often quite slow. The material costs are really low, but the labour costs are really high. So you tend to see sort of cob and Strawbale being done, or cob rather, being done as a self-build, because it's not very high tech, and they've got plenty of time available if you're self-building, and the material costs are really, really cheap. Again, unfortunately, I've never had the pleasure of doing any sort of cob or clay lump myself, which is a bit of a shame. I know Hudson architects are involved in the project looking at cob, so perhaps that's something we can all look at in the future. Strawbale comes in sort of two main systems of Strawbale. One is traditional rectangular straw bales out of the field, and then you kind of nail them together with really, really long pins, and then you use ratchet straps and you kind of compress them into a shape, into a wall, and then you load it up with a roof as soon as humanly possible, and then you kind of carry on with the build. And then the other system is to use straw within a timber frame, as per the image on the right. This particular one is called EcoCon. I quite like this. It's a really quick system, and it got used on this house, which is the late great Martin Newton, who was one of the sustainability and energy guys at the University of East Anglia. Architecturally, it's not a particularly interesting house externally. Inside, it's probably my favourite house. It's used clay plasters internally. We've got MVHR in there, so the air quality is really, really high. There's no gypsum plaster. It's a beautiful building internally, and Lil, Martin's widow, is really keen for people to come and see this building. It's a Passivhaus in terms of its standard, and it's a really, really nice building to kind of get people thinking about materials. It's got a lime render externally, and as I say, a clay plaster work inside. It is genuinely worth a visit as a building to admire the internals, not the externals. As a system, it was really quick to put up. I think they did the whole of the straw in a week. So, you've got a building with a roof on within a couple of weeks. So the actual putting the timber frame together with that straw in it is a really fast process. Obviously, the clay plasters, if you're doing that by hand, and they had like sort of family days where they sort of got 20 people and a barbecue going, and they all started splattering clay everywhere. That is a slow process, and perhaps that's where we need as an industry to think about how we could speed that process up, such that it could be used in proper buildings on proper sites, and perhaps even adopted by volume house builders, because it's a very low embodied carbon way of building our housing stock. Plastic, I've just given you a selection of those. EDPM, so that's your sort of single ply membranes on roofs. I did do quite a lot of reading. You can recycle it, and Firestone are looking at recycling EDPM, but not if it's glued down. So they're looking for sort of mechanically fixed methods of doing flat roof construction. And that kind of takes us perhaps into just thinking a little bit about how we use our materials and how we put our materials together. At the moment, we think about sort of CDM and health and safety. You're obliged as designers to think about how that building is going to be built and how it's going to be dismantled. And we probably need to think about how we dismantle a building from a recycling those materials perspective in the future. Your choice of glues and adhesives or mechanical fixings might determine whether or not that material could be recycled at the end of its life. And those decisions that you make will have an impact on those in 60 years' time that then start to fiddle with your building. So they're the things that perhaps we need, we're just in its infancy sort of thinking about this, and perhaps we need to give it a lot more thought. All of those materials, they're oil-based, and as you can see, they've got quite a high sort of amount of energy embodied in them. You've got over 3 kilograms of CO2 embodied per kilogram of material. Now, obviously, these are being foamed up, and most of them are lightweight, so you obviously your 3.31 kilograms of embodied carbon will go quite a way, but they are energy intensive. And although most of these materials can be recycled, I haven't seen much evidence that we do actively recycle these and put them back into materials, either UPVC windows and or insulation materials. I think it's coming, but it's not really happening in a way that it should. Yeah, gypsum. There, we all think about our 3 mil skim, don't we? You know, a bit of plasterboard, chuck it up, skim it out, and off we go. And we don't really think about plaster, but it's an anhydrite binder. So that's what's that? Calcium sulfate, and most of it comes from coal-fired power stations, unbelievably. And we discovered with acid rain that most of these coal-fired power stations were belching out all sorts of sulfurous fumes. And so they started to desulfurize the gases that were coming out of the flues at coal-fired power stations. It's an electrostatic process. So it's like a mesh that's electrostatically charged, and then the kind of this sulfur products kind of fall out. And so we're actually using gypsum plasters that are based on coal-fired power stations. And so the question is, what happens when we stop burning coal? Where's this plaster going to come from? Are we then going to have to start kind of digging more holes in the ground? I mean, it's a common enough material. But at the moment, we're making use of it as a byproduct. And don't forget, things like naturally occurring gypsum actually end up in your toothpaste and cosmetics and God knows what else. So it's going to become probably more expensive as a material once the coal-fired power stations are shut down. And we probably need to think about where these materials are going to come from in the long run. So it's an interesting material, and it's an interesting future that it's going to hold for it. I'm only going to touch on this ever so briefly, because I do get asked quite a lot about sort of thermal mass in Passivhaus. So, i.e., do you build a huge, great, really dense concrete building, or do you do a lightweight timber frame in terms of thinking about thermal comfort? In the round, Passivhaus isn't overly excited about high thermal mass. It does take it into consideration within the calculations, but it would rather you think about it on a daily basis, not over a seasonal basis. You don't want that building in summer to get ever so slightly hotter on each day. So in really, really high temperature periods, really hot summers, you don't want it to be 21 degrees one day and then 21.5 degrees the next day, then 22 degrees, da, 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 da. That's not what you really want. So try and think about thermal mass and what it can do for your building on a daily basis. It can certainly ameliorate the maximum temperature that you find. And certainly if you ever walk into somewhere like Norwich Cathedral on a really hot summer's day, you can really see the benefits of a high thermal mass. The downside to it is that it tends to shift the peak temperature to later on in the day. So you get this sort of, 4 or 5 hour shift. So typical peak temperatures are perhaps 2 or 3 in the afternoon. And what you tend to find in a high thermal mass building is that your peak temperature is actually reached at 5 or 6 o'clock in the afternoon, which in a house is when you get home. So be really mindful about perhaps high thermal mass might make sense in an office building, might make sense in an educational building. It might make less sense in a house, perhaps. So just be really careful about thinking about thermal mass. Now, as I said right at the beginning, Passivhaus wasn't really interested in materials, and it wasn't really interested in embodied energy. That is starting to change, and there is a lot more research, a lot more talk within Passivhaus circles about embodied energy. And here in the UK, the Passivhaus Trust and the AECB, so that's the Association of Environmentally Conscious Builders, it's such a thing. They've been working with a guy called Tim Martell, and he's developed a piece of software that plugs into the Passivhaus planning package software and picks up about 80% of the materials used in the building. And it means that we can quite quickly now work out the embodied carbon within a building by modeling your building in the Passivhaus software, effectively pressing some extra buttons, and then it's telling us what that embodied carbon is in that building. And what I've put at the bottom thing is to improve the performance looking at embodied carbon, we need to start by measuring where we're at now. At the moment, if I asked any of you, lovely ladies and gentlemen, what is the embodied carbon of your building that you've got on your sort of design desk today? Taking a lot of data that we're entering into the Passivhaus software and reusing that data and taking some RICS data about embodied carbon, and it's then starting to tell us what the embodied carbon is for the whole building. So it's pretty straightforward. What used to take sort of days and days and days, and the thought is that we should be able to produce meaningful results for you within about a day's work, which is much more useful and cheaper. So the outputs available at the moment is we can look at CO2 embodied per person, or the CO2 embodied per square metre of the building, or per building. So it's an opportunity to look at you sort of either, as I say, per building or per wall type. So if you want to compare different walls and look at the embodied carbon, we can start to do that. The thing, it's still kind of, it's still being formed, it's still coming together. There's still lots of data missing. And also transport of these materials is really important in the overall figures, and that's in its infancy. Understanding how far has that brick travelled? Has it actually come from Belgium, or has it come from Peterborough, or wherever we're still manufacturing brick in the UK? So it's really interesting. There's a lot of data missing, and there's lots of stuff that we still need to put in, but it's a start. It's a really good start. The other thing that's missing is understanding how recyclable those materials are at the end of their life, in terms of if I use a brick wall and I use lime mortar, it then becomes much more easy to recycle and reuse those bricks again in the next building. How do I capture that in these figures, in this initial building? How do I think about those materials being used in the next building and the building after that? Roman brick is still kicking about in various walls and stuff in the UK, and they're 2,000 years old. Brick, in theory, can last forever if it's looked after and treated correctly. So it's a long way to go in terms of understanding our embodied carbon, but we're getting there. We're starting to be able to offer a service as a group of professionals that can say to you, this is the embodied carbon of your project, and these are ways that you could potentially reduce the embodied carbon. So one of the ones that Tim had on his website, and so I have sort of lifted it. So Tim Martel is the guy he's the author of all this sort of stuff. He was showing that a typical semi probably contains about 10 tons of embodied carbon, and he reckoned that some of these Passivhaus buildings, the total carbon in terms of in-use operation carbon and the embodied carbon may only be 14 tons. So there's opportunities here to look at how much carbon is embodied and the total amount of carbon in that whole lifetime of that building that's going to get used. We're starting to be able to put some answers in, and we're starting to get some data. So it's really interesting stuff. As I say, it's still work in progress, but it is an excellent tool, and it's something that we as a business, we hope to try and trial and use sometime in the near future. I think it's fascinating stuff. Now, you could all say to yourselves, I'll carry on regardless. And I say to you, I think that's a plausible plan for the next 4 or 5 years. I think you'll get away with it. You might even just get away with it up till, say, 2030. But I think, and you can see with what the government announced with their 10-point plan, you've got COP26 in Glasgow next year, COVID depending. You've got Biden now as president. You're going to see quite a lot of pressure now coming on, looking at carbon and our energy use. We're talking about electric cars, electric heating. And so I think we will come to a point in our lives where we will be given a carbon budget or a carbon tax as individuals. And I think the building industry is on track at the moment in the UK to be the next coal industry in terms of bad PR. Who wants a job at a coal mine in terms of thinking about carbon emissions? It's not really the sort of thing you want to kind of put on LinkedIn going, oh yes, I work in the coal industry. And if we're not careful, I think the construction industry is going to end up as the next coal industry. Let's not go there, but I think that's where construction is going at the moment. I think as individual professionals, I think there's a reputational harm if we keep knocking out designs that are high carbon and very poor in terms of energy performance. I think you're going to become socially unacceptable, whether you like smoking or drinking and driving. I think your attitudes are starting to change, and we as a business are getting to that point where we are probably going to start to say to clients, I'm really sorry, we'd love to work on this project, but it really isn't for us because it's not Passivhaus. I think that's where we're going, and I think that's where we all need to go, pretty sharpish. And I think we will, kicking and screaming, but we will get there. There's a Scottish consultation document out at the moment saying that you won't be able to buy or sell a poorly performing building in terms of its EPC rating. Now that's going to have a monumental effect on people's attitudes to energy performance of buildings. And there's no reason why that kind of stricture won't end up here in the UK, in the rest of the UK, if Scotland doesn't become independent in the meantime, if it happens in England and Wales in the next few years. So just be mindful that our environment around us, our macro environment around us is changing rapidly. And I think if you don't change and others do, you will eventually get left behind. So if you think I'm just a bit of a geek and a bit of a nutcase and you're thinking I'm out on a limb here, this was last week's Tory graph. Major house builders ditch plastic as they replace material with mushrooms, seaweed and bamboo. They were looking at taking plastic out of insulation materials and basically changing some of the materials that get used in buildings. And as you can see, the headline then goes on to say 50,000 tonnes of plastic waste are produced by our industry each year, and 40% of that goes to landfill. I would suggest that carry on regardless isn't necessarily a good option. So conclusions, and I've actually done quite well time-wise, I hope. So conclusions, low energy buildings are a must, otherwise our electricity grid will never cope. And I personally don't think hydrogen is going to be our salvation, unfortunately. And therefore, I also think that low embodied carbon buildings are going to become commonplace. I really think that it's in its infancy and we're all going to ignore it for another couple of years. And then it's going to be wham, bam, what's the embodied carbon in this building? And we're going to go, and it's coming. I know it's coming. And people are really going to be talking about this much more than they are. And I think we need to educate our clients about low energy buildings, about embodied carbon, such that they don't end up with stranded assets, because that's the way it's going. If you owned a coal mine, you are going to end up in an oil well and gas well eventually, you are going to end up with stranded assets. They're talking about trillions of dollars of stranded assets globally. And there's no reason why your clients with building assets can't end up with stranded building assets. So that's my spiel in a nutshell. I hope it's kind of, I wanted to do a speech that was kind of just to get you thinking about embodied carbon, necessarily trying to give you specific answers. So I just wanted to kind of set out an idea about where we are going. So hopefully it was of interest to you all.
Great, thank you, Alex. I thought that was really interesting. Lots to take in there. I was just thinking about all these calculators. I don't know if you've seen that. I was looking at something recently that Field and Clegg Bradley have produced a carbon tool where you can put everything. I don't know if you've had a look at it. I was looking at it the other day because they're running some webinars on how to use them.
Yeah.
I haven't looked at any detail in how easy these things are to use yet, but I was quite interested in that.
Yeah.
They might be quite useful, I think.
I mean, certainly where we are, I mean, we're getting a lot of work and a lot of inquiries looking at producing Passivhaus models and to try and optimize the performance of buildings, whether that be care homes, school buildings, private dwellings. And so if we're putting all that data into the Passivhaus software, which is just a giant Excel spreadsheet, if we're able to then press a few extra buttons and spend a bit of time putting in some extra data, and then we're able to give you a embodied carbon fairly simply, then hopefully it means that people aren't putting lots of data into lots of different software packages. I think hopefully that would be an advantage. And it would be nice perhaps in the future to have some sort of BIM type software that you guys do all your design and you can press some buttons and it tells you whether or not it's going to be Passivhaus, whether or not it's going to overheat in the summer, and it tells you what the embodied carbon is. Wouldn't that be fantastic as you're drawing and you're thinking about your models at the initial design stage? That sort of data was being spat out at you. It might change the way that buildings get developed. So. Yeah,
definitely. I mean, I definitely think that would be, the way forward. It makes you think about lots of other things as you design, the BIM model. Then makes sense to have that kind of information coming out of there. So yeah, absolutely.
I'm making myself redundant, aren't I? Because you need it.
Yeah, that's true. Don't do yourself out of a job. Does anybody else have any questions or comments at all? If you want to either put them in the chat or unmute yourself and switch your video on and ask the question yourself, feel free. I'm getting some comments here on the chat with lots of people saying very interesting, amazingly interesting, useful and thought-provoking, very interesting. I think you've definitely got everybody thinking tonight, Alex. Yeah, any questions from anyone at all? Everyone still. We've got a question here, Clark Penman. I don't know if you want to unmute yourself or bring yourself on, or whether you prefer me to ask for you.
Hi.
Oh, here we go.
Can you hear me?
Yeah.
Hi. Yeah. Thanks. Really interesting presentation. Our practice works a lot in, or with, or on listed buildings.
Yes.
Some of which we're able to install products such as Thermoblock, where we use a high recycle content with a carrier board,
Yep.
lime plasters, allowing a hygroscopic movement between the external faces and the internal renders. Quite often we come up against issues with planners. Moreover, it's quite a buy-in from a client's perspective.
Yep.
And the trump card is always, it's a listed building. Stop. Don't
Yep.
talk anymore.
Yes.
Preserve what it is. And I fundamentally, in some ways, I'm a conservationist. In other ways, I'm a modernist in terms of exactly attuned to what you've discussed about selection of materials and certainly unpicking them, which is very much a part of working with listed buildings, is being able to read, having legible construction techniques, which can be either re-strapped, rejointed, and reappropriated in a sympathetic manner. But apologies, I'm rambling. I'm just interested in what your thoughts are. Thank you.
I mean, I'm very lucky to live in a tatty stone cottage in North Norfolk that's Grade 2 listed, and so I've got a lot of time and empathy for thinking about how to look after that building that's already, well, the bottom half is probably sort of 300 or 400 years old. The top half is Victorian, so it's a bit of a mishmash. But it makes you think about the materials that have used. And unfortunately, in the 1980s, my particular house got sort of Bob the Builder turned up, and he plastered sort of cement renders all over the inside of it. And for me, thinking about that building in terms of making it more or a lower carbon building in terms of moving to a low carbon heat source and to reduce the heat losses, I need to tackle those flint walls. And the only way to do that is to spend an awful lot of money in terms of stripping those walls back and then applying like in French they call it a ravage, and sort of like a lime plaster skim coats to give you a flat surface, and then to sort of put on sort of wood fibre insulation boards like Heraclith or Passivhaus, and then lime plasters and renders internally, and then sort of traditional distemper paints. They're all kind of reasonably low carbon, they're all kind of breathable, and that's what I'd love to do to that cottage. But to do it properly, I reckon I'd end up, I'd lose quite a lot of floor area, but I'd probably end up spending 30 grand. And it's trying to justify the expense of spending that kind of money on refurbing buildings. And I think it's about looking after buildings and thinking about the next generation. What are they going to inherit? And I really want to make the right investment, and I'm hoping that our government, it's a forlorn hope, I'm hoping our government will help us kind of perhaps via grants or some sort of reduction on council tax, whatever, give us that environment to allow us to actually take old buildings and to renovate them and to incorporate new materials within them, such that they can be taken apart again in the future. And I think the great thing for me about an old building is that you can see its history. When you start peeling back the layers, I find that fascinating. And it'd be really nice for future generations to be able to peel the buildings back and understand what we were trying to achieve, and to see when we did stuff and what we did and whether or not it worked, I guess. So I genuinely, I actually prefer old buildings by a long chalk. I find them really interesting, and the building physics side of it in terms of the moisture movement through them, I also find sort of highly fascinating. I use Woofy as a piece of software that sort of dynamically models moisture movement over periods of time through walls and things. So it's very much on our kind of radar of what we could do with old buildings. And so yeah, I think what worries me probably the most, having looked at it today, is retrofit coordinators. You can train for about 300 quid to be a retrofit coordinator, and it worries me that these guys and girls are going to turn up and start pressing various buttons on bits of software, and all sorts of inappropriate interventions are going to be made on old buildings. And I really don't think a £300 piece of training is going to be adequate to make a retrofit coordinator competent to deliver what we need to do as a nation. I think we've got the Green Deal kind of debacle about to hit us again, unfortunately. It's a real shame. But it's a fascinating future in terms of retrofit. There's 20 odd million buildings that we need to retrofit. Even the stuff Persimmons are building this week, they will need retrofitting by 2050. It's a huge task. We need to be retrofitting something like one house every 30 seconds between now and 2050. It's just bonkers, the whole scale of what we need to do. But old buildings, I love working on them, and I'm really, I like people that work on them and treat them sympathetically. I'm not a big fan of people that buy a clay lump barn and then cover it in Silatex.
Thank you, Alex. Thank you. Oh, sorry.
That's fine. There was somebody put up I can't say it's called, disappeared off the messages. There was something about how do I find the enterprise centre, I think, wasn't there?
Yeah, that's the next question, actually. Andrew Burbage, did you want to come on and?
Yeah. Yes, thanks.
Here he is.
Hi there, Andrew. I work at the University of East Anglia, so got an interest in.
I'm glad you flagged that up first.
Okay. Interesting to a couple of your reference, Martin Newton, bless his soul. I was a colleague with him, so
yes,
yeah, good to hear about his story in that respect.
It was such a great guy, and I can't believe that he's gone. It's unbelievable. So sorely missed. I really enjoyed his company. I enjoyed working on his house with him. It's a really fascinating project, and as I say, Lil, his widow, is really keen to showcase the house. So perhaps when COVID lets us out, perhaps that's something the NNA would like to do, perhaps next summer or something. That'd be really, she would like that a lot. And I know that Martin would like that a lot. So,
yeah,
definitely.
That's great.
We'd definitely be interested in that. Martin helped us out with some lectures last year. So yeah, we definitely.
Yeah. Okay.
My question really related to the enterprise centre, and I see that you've got an office there, Alex.
Yes.
Whether you occupy it or not, I don't know. But just
We're hiding at home at the moment.
Yeah, I know. In good times.
Yes.
Just interested in how you see it as a performance-wise as a building, and also from a building aspect.
I mean, in the round, as an occupier, it was interesting the way that the designers approached it. So to start off with, there's no light switches, which was a bit weird. So that kind of takes a bit of getting used to. And there weren't any microwaves fitted because that was going to use too much electricity. So it was all a bit odd in terms of how it was originally set up. And then once people sort of moved in and we started using it, and people kind of started to find ways around the fact that there's not enough electric sockets around the building, it kind of turned into a really, really good building. I really enjoyed the building. It's a quite a thick concrete slab sitting on polystyrene. The concrete is a polished concrete floor with 70% slag, so it's a reasonably low embodied concrete. You ended up with a really creamy, pale, exposed concrete finish to the floors. Really nice. I like it. In terms of, you need the occupancy in the building, because when the first sort of winter, there weren't enough of us in there, and actually there wasn't sufficient internal heat gains, and so the building was slightly on the chilly side. But now that it's kind of been in use longer, I suppose this winter might be a problem as well with COVID. But in general, if the right number of people are in the building and it's getting used as it was meant to design, it was brilliant. It says what it does, on the tin. It's a brilliant product. Interesting sort of bit of shenanigans was that the heating was provided by the hot water ring main that's on the university campus. And as I understand it, there was a little bit of skullduggery to hide the kind of carbon that kind of goes with the hot water as such, as I understood it. But it's a fabulous building. You can't knock it. It's a great building. And I really enjoyed being in there. And it had lots and lots of positive response. So when we had visitors coming to visit us, and they all wanted to have a quick wander around, they all kind of fell in love with the building. And don't forget, it's got sort of interior clay plasters, and there's sort of nettle kind of mesh and stuff, isn't there, made out of nettles and bamboo and things. There's some fantastic natural materials inside. So it is a really lovely building. Yeah, it's great. And it's a shame that not every building is kind of given as much care and as thought to its design and construction as that building. Wouldn't it be nice if every client was enlightened enough to produce buildings like that de rigueur? It'd be great. Unfortunately, we've got a long way to go.
I think we have to have deep pockets as well, knowing the cost of the building. But
yeah, I think that's true. But it depends how we value cost. I could build you something really cheap, and at the moment with COVID, you're going to have ram loads of air in it, and you're going to have an enormous gas bill trying to keep it warm. And so I think we need to think about our whole cost of, and of course, if some sort of carbon costing comes in a more meaningful sense, do clients end up paying a carbon tax in future, and therefore will that building somehow kind of pay for itself in unexpected ways in the future? And there's all sorts of possibilities out there how our future is going to be shaped by our politicians. But it's a future-proof building from that sense, and I think it deserves the merit, and the accolades that it got.
thank you. Good to hear.
Thank you, Alex. Thank you, Andrew. See another question down here from Chris.
Yep.
Chris, did you want to unmute yourself and talk, or? No, maybe not. But Chris says, is the next greenwash going to be applied to embodied carbon? Chris's question.
Yeah, I think there's a risk with anything, isn't there, in terms of the greenwash could be applied. Hopefully we're all becoming a bit more sort of worldly wise and a little bit more cynical about claims made by manufacturers, and calling yourself green this, eco that perhaps doesn't really kind of tick the boxes anymore. And of course, there's no reason why in the future we can't do some modelling and go, actually what you're telling us is incorrect, and start sort of embarrassing people with their data. I mean, I remember the sterling price for the Bloomberg building in London, and there was all this big thing about, it's a fantastic low-carbon building. It was an enormous behemoth covered in bronze or whatever. I mean, it was just bonkers from a sustainability point of view. And I think it's where, as professionals, we need to be kind of put our hands up and go, it's a lovely building, but there's nothing sustainable about that building, and let's be honest about it.
Yeah. Chris has put an extra comment here. He said his mic is not working. He said, maybe I am too cynical. I meant by manufacturers who want to sell us / clients. Yeah,
sure. I mean, my experience, and it was brief experience, so I wasn't kind of hugely involved, but I did go to a few, as I say, the green guide meetings that the manufacturers had put together to try and guide the green guide from the BRE. And in essence, just to give you a very quick 2-second flavour of what was going on, was the steel boys wanted to take the carbon savings from the slag element of our production, and the concrete boys wanted to take the carbon savings from our product because it was a waste. And so they were both vying for our carbon emissions. So it all became a bit of a game as to who could grab our carbon savings by using slag in concrete. And coupled with that, there was this thing of going on, and I didn't understand it at the time. I had to go away and read up. They were arguing over whether or not they should use a British citizen or an EU citizen. And the reason behind that was that a European citizen, on average, consumes more concrete. And so there was all this sort of lies, damn lies, and statistics going on behind the scenes. And Trada was pretty grim at bending stuff, making sure that every building was based on a 60-year design life, because they didn't think timber frame would last more than 60 years. The concrete boys are trying to take lumps out of the steel boys, and the steel boys are trying to take the lumps out of the concrete. I mean, the whole thing was just, it was entertaining but depressing at the same time. And then I think we could do with like a BRE that became independent again. Because it's funded largely from sort of private sector work, it's kind of lost its integrity, I would argue, and that perhaps it needs to be a publicly funded institution again, and then it can give us objective data and be objective about stuff and not be kind of lobbied by one industry or another, which is where a lot of this data comes from. And you look at the Grenfell inquiry of talking about fire ratings on products, and they started changing the formulations and making it much more dangerous in terms of fire. The manufacturers do have a lot to answer for. Also, manufacturers tend to have the best brains. So if you want a really good technical document written, you need to ask a manufacturer to help you write it, because often they've got the best boffins. So it's a difficult tightrope to walk.
Okay, thanks, Chris. We've got one from Amar. I don't know if you're still here. I don't know if they are, but their comment is, I've noticed in a house that was retrofitted to Passivhaus standard, but is only an EPC C rating.
Yep.
Any thoughts on this?
Probably because RDSAP, it's dependent. There's very little data that goes into RDSAP. You tell the software how old the house is, you tell it the floor area, and you tell it the ceiling heights, and then press some buttons as to what you think the U values are, and it spits out an answer. It's a tool designed to help you compare one house to the next house if you have 10,000 houses. It's a kind of quick and dirty guide to sort of residential social landlords as to which houses need the most work doing to them in what order. It's not really a tool to tell you the performance of that house, really. It's, as I say, it's a comparative tool, and it's certainly not a design tool. And we use SAP as a design tool, and I hate that with a passion. I hate telling architects, oh, you need to do this, that, and the other to make the SAP work. It shouldn't really be like that. We should be designing houses better. And that's where Passivhaus is a much better tool. It is a design tool. In terms of the answer to that question, I suspect it could be if it's a heat pump, they don't tend to score well, because SAP rating is telling you about the running costs of the building. It's not really about the energy performance of the building. It's how much does it cost to run. And if you've put a heat pump in and electricity is 16p a kilowatt hour and gas is 4p a kilowatt hour, your running costs are going to go up. So that would be one of the areas I'd be looking at, and also whether or not the guy put in some sort of default air pressure test result, and also a linear thermal bridging, whether or not there was any data put into those. So that's probably what drove it. And just so you know, the houses at Goldsmith Street, which were certified Passivhaus, they were with gas boilers, they were all B ratings. So you do not necessarily get an A-rated house by building a Passivhaus. SAP is very sensitive to renewable technologies and not very sensitive to fabric, and that's why we shouldn't use it as a design tool.
Okay, thank you.
Alicia asked about whether or not Passivhaus will be in planning policies.
Yeah, I was about to read that.
I think that's over I think that's over the government's dead body. For whatever reason, they just don't want to do it. And in Future Home Standard, there is a nod to Passivhaus. But it just doesn't, they don't put their hands up and go, do you know what, Part L has been a disaster for the last 20 years, Part F and Part L together, they don't go together very well. Do you know what, stuff it, we'll do it to the Passivhaus standard. They should, but they're not going to. There's too many vested interests, there's too many lobbyists behind the scenes pulling the strings. But I'd love Passivhaus to be the planning policy and the default building control policy to demonstrate compliance with Part L. It's not going to happen, unfortunately.
Okay, thank you, Chris. Sorry, thank you, Alex.
No problem at all.
Thank you. Charlotte has also asked a question here. She says her microphone's not working. She's asked, you can probably read it, but clients are often driven by costs, and Passivhaus buildings are generally considered expensive buildings despite the running costs being low. Is this still true?
Well, so what we're finding, because what builders were doing with buildings that were Passivhaus was they hadn't done one before, they were risky, so they were pricing in that risk. And so you were starting to see prices of 20, 25% above. if, and it's a big if at design REBA stage 1 or 1 and 2, you've got a sad geek like myself, or you are an architect and a passive house designer, and you design that building from the outset with passive house in mind, we think we can get building costs within 2 or 3%. And in fact, we're working with a county council sort of further west from here, looking at their care home provision for the future. And they have decided they are going to build a passive house because actually the extra over cost of building to that standard is negligible, but you get all the benefits. And hands up, who's been to a care home? Okay, I've been to a care home. They're a bit smelly. Shh. So if you've got good air quality, which a passive house will give you, hopefully it might be a nicer place to visit. And also, grannies like to be kept warm, 27, 28 degrees centigrade. So what better building to build to passive house standard? One that reduces your energy bills dramatically, and you can run it at a higher temperature with much lower bills. So for me, granny homes to passive house standard are a no-brainer, absolute no-brainer. And we should build them as standard to passive house, because it doesn't matter what metric you use, it's idiot proof to kind of go, because they're often big buildings, so form factor is good. As I say, air quality is better, the running costs are better. It's just, why wouldn't you? And to be fair to this particular council, they're going, why wouldn't we? And that's what they're going to build. And we're seeing it with school buildings. And Archetype have done quite a few school buildings to passive house standard, and have done them very competitively cost-wise, because you can strip out a lot of M&E. There's no cooling required. You can put in less heating. So there's huge opportunities if you design the building at outset to passive house standard. If you're retrofitting, and Goldsmith Street effectively was a retrofit, it was a design that got pacified, it's really difficult, and it tends to push the price up.
Okay, great. Thank you, Charlotte. Thank you, Alex. Anybody else got any more questions? We've had lots of comments saying very interesting.
Okay.
So I think that was really great. Okay, well, if there's no more questions, just leaves me to thank you, Alex, for giving up your time. Thank you for coming to do that for us. Really, really interesting. I think everyone found that really informative. Obviously, lots of questions. So, yeah, a lot for everyone to think about.
Yep.
That's great. Yeah, thank you very much for joining us this evening.
Perfect. Yeah, well, good luck to everyone out there in these strange times that we're living in.
Indeed, yeah. Well, thank you everyone who joined us this evening and for all our other lectures. And we'll be in touch about our next event. We're hoping to hold a Christmas quiz. So yeah, we will let everybody know. But thank you very much for this evening.
No problem at all. Yeah, nice to meet everyone.
Thank you.
Take care. Bye-bye.
Bye-bye.
Bye.